How's it, guys? In this video we are going to look at how to differentiate functions of the form u over v. We make use of this rule here, which is known as the quotient rule. It states that when y is equal to u over v, then dy by dx is going to be v du dx minus u dv dx, and that whole thing must be divided by v squared. An example to demonstrate how we make use of this rule is given here. If you have a look at this quotient, the numerator is always going to be equal to u and the denominator is always going to be v. So as part of our solution, we have identified that u is equal to x squared, then du dx has got to be equal to 2x. Similarly, if v is equal to 1 plus 2x squared, then dv dx is going to be equal to the derivative of 1 is 0, so the derivative of 2x squared is going to be 4x. Now plugging this into our formula, dy dx is going to be equal to v, which is 1 plus 2x squared multiplied by the derivative of u, which is 2x in this case, minus u, the original function u is equal to x squared, multiplied by the derivative of v, which we obtained as 4x, and that whole thing must be divided by v squared, and v in this case is 1 plus 2x squared, and that whole thing has got to be squared. Now we're just going to tidy this up and expand the bracket. In the numerator we'll have 4x squared plus 2x minus 4x cubed. Sorry, this is also 4x cubed because 2x squared times that is going to be 4x cubed. And then there is no need for you to expand the denominator. You can leave it as 1 plus 2x squared, and that whole thing squared. And ultimately my dy by dx is going to be equal to 2x all over 1 plus 2x squared, and so this here is what your dy by dx is going to be equal to. Let's have a look at a second example, which I'm going to call EG2. In this case here, you're given that y is equal to 3x plus 1, and this is divided by the square root of x squared plus 1, and we again are asked to find what dy by dx is going to be equal to. As before, we're going to call the numerator u and the denominator is going to be equal to v. So if u is equal to 3x plus 1, then du dx is going to be equal to 3. And similarly, if v is equal to, firstly I'm going to convert this into x squared plus 1 to the power of a half. Now we're going to need to make use of the chain rule to differentiate this expression here. If you are unsure of how to make use of the chain rule, I encourage you to look at one of my videos that looks at how to differentiate a function of this form here using the chain rule. Okay, so to do that, we agreed that you will multiply by the power. In this case, the power is a half. You find the derivative of what's inside the bracket, which is going to be equal to 2x. And then we're going to subtract 1 from the original power, and so that is going to give us minus a half. Okay, so a half minus 1 is going to give you minus a half. Simplifying this is going to give us x all over x squared plus 1, and that is raised to the power of a positive a half if we bring it down to the denominator. Now we are going to go and substitute this into our formula. So your dy by dx is equal to v du dx minus u dv dx, and that is all divided by v squared. So plugging in those values that we found, x squared, the square root of x squared plus 1 is the same as this here, multiplied by du dx, which is equal to 3, minus v. We found that we're given that it's equal to 3x plus 1 multiplied by dv dx, which is what we got here. Let me tidy this up. It's going to be x divided by the square root of x squared plus 1, and that is to the power of a half. Alright, and this whole thing here has to be divided by the square root of x squared plus 1, and this expression must be squared. Okay, I'm going to endeavor to write the numerator as a single fraction, and if I do that, I'm going to have this here, 3 multiplied by x squared plus 1 to the power of a half, and minus 3x plus 1 multiplied by this x here, which I'm going to put at the start here, and this is divided by x squared plus 1 to the power of a half. Now this one is over 1, and it's still divided by this expression here. The square root of x squared plus 1 squared is going to be equal to, so this single term here must be divided by, because this line means to divide, it must be divided by, the simplified expression is x squared plus 1 all over 1. Alright, if I make some space here, we are going to have at the top, if we make the denominators the same, it means we need to multiply this one by the square root of x squared plus 1, and whatever we do to the denominator must be done to the numerator. So we are going to have 3 multiplied by x squared plus 1 minus x into brackets 3x plus 1. All this is now over x squared plus 1 to the power of a half. Now if we change this to a multiplication sign, if we are dividing by a fraction, we all know that we can change that into a multiplication sign, and then we invert the given fraction into this here, x squared plus 1. Alright, and then I'm going to get rid of the brackets in the numerator, and that's going to tell me that we have 3x squared plus 3 minus 3x squared minus x, and the numerator times the numerator, in this case it's 1, so I'm going to have that as the result. And this one here, if the bases are the same, we maintain the base, so we'll have x squared plus 1, and then we're going to plus the power, so 1 over 2 plus 1 is going to give me 3 over 2. Alright, and then the final result is going to be found by grouping like terms in the numerator, 3x squared minus 3x squared, so these two are going to cancel out, and then we'll have 3 minus x all over x squared plus 1 to the power of 3 over 2 as my dy by dx. Okay guys, I have one final example which we are going to call EG3, and it is given here. It says that find the x coordinates of the turning point on the curve y is equal to x squared plus 4 divided by 2x minus x squared. I encourage you to pause the video and attempt this question on your own, and then you can play back the video when you're finished so that you can compare your solution against mine. Welcome back. If you found your answer to be this here, then well done. If not, let's go over the solution together. So we all know at this point that the coordinates of the turning point or the stationary points on a curve occur when a dy by dx is equal to 0 at the stationary point. So what we will need to do or the stationary points are also referred to as turning points. So what we will have to do is find what dy by dx. If you look at the given function, you can see that this is a quotient because you have a u and then you also have a v at the bottom there. So if u is equal to x squared plus 4, du dx is going to be equal to 2x. If v is equal to 2x minus x squared, dv dx is going to be equal to 2 minus 2x squared. From here on, we are going to say that dy by dx is going to be equal to v, which is 2x minus x squared multiplied by the derivative of u, which is equal to 2x minus u, which is equal to x squared plus 4. And be careful because we have to multiply everything beyond this point by this negative there, and that's multiplied by the derivative of v, which is 2 minus 2x squared. This whole thing must be divided by v squared, and v squared is equal to 2x minus x squared, and that whole thing has got to be squared. As I've said to you in the first line, dy by dx has got to be equal to 0 at the turning point, so we need to solve this equation here for x. Now expand in the bracket. Well, firstly I'm going to multiply throughout by this denominator here, so we are going to have 2, okay, and then expand in the bracket, so 2x multiplied by 2x is not going to be 2, but it's going to be equal to 4x squared minus 2x cubed minus, and then this one here is going to give us 2x squared minus 2x cubed plus 8 minus 8x, and that is going to be equal to 0 because we've multiplied both sides by the denominator, and that's going to cancel out. So getting rid of the bracket again means that I'm going to have this here 2x cubed minus 2x squared plus 2x cubed minus 8 plus 8x, and that is going to be equal to 0. Now collecting like terms means that I will have 4x squared minus 2x squared, it's equal to 2x squared, so these two terms are taken care of, minus 2x cubed plus 2x cubed, that will give us 0, and then I'll have plus 8x minus 8, and this is equal to 0. Now this is a quadratic equation that I can solve. Then I'm going to divide throughout by 2, giving me x squared plus 4x minus 8 is equal to 0. Unfortunately, I cannot factorize this, so I'm going to have to make use of the quadratic formula. So x is equal to minus b, which is equal to 4, minus 4 plus or minus the square root of 4 squared, minus 4 lots of a, which is 1, multiplied by, sorry, this is meant to be equal to minus 4 after having divided throughout by 2 in this line here, so that is going to be equal to 4, and then this is divided by 2 lots of a again, which is equal to 1. Now we're going to have minus 4 plus or minus the square root of 4 squared, and that's minus 4 plus 16 is going to be equal to 32, and this is divided by 2. This is equal to minus 4 plus or minus the square root of 16 multiplied by 2. Okay, so 32 is equal to 16 multiplied by 2, and this is divided by 2, which is going to be equal to the square root of 16 is equal to 4, so we'll have minus 4 plus or minus 4 multiplied by the square root of 2. and we can divide throughout here by 2, and if we do that we will find that x will be equal to, if I factor out 2 at the top, it will be 2 minus 2 plus or minus 2 root 2 all over 2. Now this 2 is going to cancel out with this one here, therefore my x is going to be equal to minus 2 plus 2 root 2, or the x is going to be equal to minus 2 minus 2 root 2. So these are the two x coordinates that are going to be at the turning point of the required curve. I trust that you found this to be useful, and in the next video I'm going to be looking at the product rule, which also deals with the differentiation of a different class of functions. Thank you for watching, and I'll see you in the next video. Cheers.